Okay, so I'm just going to draw the diagram of what you need. So I've got my seesaw with my pivot here, and it tells you that the weight of the plank is 270 newtons. So we can say that that acts at point M, because that's the centre of mass of the plank. I've not written that very clearly, but 270 there. So this is our point M, and it's the centre of mass of the plank. So we can say that all the weight of the plank acts there, and our distance is 0.25 meters. And we still know that the girl with a weight of 300 newtons is sitting 2 meters from that pivot. Okay, what we then have is this larger boy who has now sat down on this side. We don't know his force, but we'd like to find it, and we know that he's sitting in the same position as the other boy. So that is 1.5 meters away from the pivot. And what we know from our principle of moments is whatever our clockwise moment is will equal our anti-clockwise moment. So we're going to look at the clockwise moment now. Now the clockwise moment, okay, will be the moment caused by this force and the moment caused by this force, because they're both going to make this turn clockwise, okay? And we know, so we need the force of the at point M times the distance to point M, plus the girl's force, so the force of the girl times the distance to the girl. So let's substitute our values in here. So we've got 270 newtons times that distance there, 0.25. And we've got to add that to the other moment caused by the girl, which is 300 newtons, times by her distance, which is 2. Okay, and that will be our clockwise moment. So I'm just going to do that sum now. So I'm going to do that in my calculator, and I end up with 667.5 Newton meters. So we know that clockwise it's got 667.5 Newton meters, and for it to balance we know that the anti-clockwise moment has to be equal to it, because that's our principle of moments. The clockwise moments equal the anti-clockwise moment. So the anti-clockwise moment will equal the force of the boy times the distance to the boy, and that's the only moment on this side of the pivot, so that's the only one we need to figure out. So let's substitute in the values that we know. We know that the clockwise moment equals the anti-clockwise moment. So I've figured out the clockwise moment here, so I can substitute that value here, because we know it's balanced, so these two are going to be the same. We don't know the force of the boy, but we do know that he is at a distance of 1.5 meters from the pivot. Okay? I now need to get rid of this 1.5 here, so I'm going to divide both sides by 1.5. So I get 667.5 divided by 1.5 equals FB times 1.5 divided by 1.5. So I've divided both sides by 1.5. I mean, you might know how to do this quicker, but this is a foolproof way of figuring this out. So we know 1.5 divided by 1.5 is 1. So we get left with 66.7.5, 667.5 divided by 1.5 equals FB, because these two cancel each other out. We then do that calculation and we get 445. So we know that the force from the boy is 445 newtons. So we can check that. So if we can just check it by doing, if we do 445 times 1.5, that should be exactly the same as these two added together. So you can just check it. So it should equal, so you can just check that both sides of this equal each other. So this is your anti-clockwise moment and this is your clockwise moment, and they should equal the same amount, and that amount will be 667.5 Newton meters.